Hare Krishna everyone, welcome back to my channel IITian. In this video, I am going to simulate a cantilever beam which is made of three different materials, and after that we apply a transverse load at the free end so that we compare our results at deformation, stress, strain. So first open the ANSYS Workbench. This one is the interface of ANSYS, and after that click to the static structure system, this one. You simply double click here or click and drag here. So double click here, this one. Here give a engineering data. So first we need to give the engineering data because our beam made of three materials. So double click here simply, this one. Structure still is already by default is given, so we need to change. If you want to delete this, simply delete from here, but we use this structure still as a one material and add a new material. New, we give a name of our new material and simply enter and give our property like density. Double click on the density and double click here, this one, and also you click and drag here like this. Young modulus, first change the unit gigapascal, and now 200. You need to give a Poisson ratio like 0.3, and bulk modulus and shear modulus automatically it will take because we know the relation in between young modulus, Poisson ratio and bulk modulus. So one over material is defined. Now new material, इसमें कुछ material by define किए होते हैं, so we take from the click engineering data source and general materials. Here too many materials, so we use titanium alone. So simply click, this is the property of titanium alloy. We click here. Now engineering data, यहाँ तीन मटेरियल आ गए, या तो और beam made of three materials by this. So simply click project and right click of geometry. अगर आप इस पर डबल क्लिक करोगे then automatically you will open in discovery geometry. So ये एक नया इंटरफेस है, but we want to do in design modular geometry. So right click and click. This is the interface of design modular. So first our origin and front face, change the unit and make a cross section a rectangle because our beam is cantilever beam. Give the dimension, yeah, we give 48, this one. This is h1, so we give this one is 20. Okay, we give this 50, this one, and extrude this one and apply geometry. After that give the depth how much want to extrude, 100, and simply generate. This one is over. So do slicing. So first generate a new origin. This one is over base plane, this one and this one, I mean zx and z and x. So change base plane zx, apply zx, and this one is blue color means z, so we need to offset z. This is the value where we want to offset slice, so simply we write 20. So our new origin shifted here 20 mm away from this base. So generate and slice, apply this plane because we want to slice here, apply and generate. See this, तो दो मटेरियल की हो गई है अपनी भी. Now we want to shift our origin here. Now the distance remaining total is 50. It is 20, so 30 is remaining. So अपन अपने origin को यहाँ शिफ्ट करेंगे 15 पे कर देते. तो generate new, yeah, this one. From where? यहाँ से करेंगे तो 15 और यहाँ से करेंगे तो 20 plus 15 35. So अपन यहाँ से कर देते इस प्लेन से offset z and 15. Yeah, ये shifted है. Generate and slicing this plane, apply, generate. So our beam made of three materials. This one. See this, first, second, third. So now minimize this and click to model. Yeah, this is the interface of mechanical model system analysis. So this one is our beam. So first we choose the material, the geometry part. Here will be show three materials, but this one, this materials, this one is third one and second one. So first solid material assign the structure steel automatically. So okay, and second one assign the new material, this one, and third will be structure steel. Structure steel is already defined, so titanium. So this is our this first material is structure steel. This one is our new material and titanium. This one. So material part is completed. Now go in the meshing, because do meshing we find a better result. So click on the mesh and by default we change here 0.002 and we will use a fine mesh for better accuracy. So here coarse grain fine and generate, solve. So mesh is defined. Now we need to give a loading condition, insert and fix support, click through with control. So select three faces, this one and fix support. Yeah, three faces. Now give a force in the tangential direction. Here first change here a component. So click through with control. Yeah, we select three geometry part, three faces and give in only y direction, mean negative y direction. So use minus sign and give a force 5 Newton. Yeah, see here this one and click right click and insert solution, deformation, total deformation, insert insert strain von Mises theory, insert stresses equivalent and solve. It will take some time. Finally we get the results. This is total deformation, this is